Hello everyone and welcome to the new session. In this video I'm gonna show you how to configure VXLAN Lab using BGP EVPN. As you know, in previous video we already configured the same. However, in previous video we had two server has the same VLAN and same subnet in different location. In this video we're gonna do something else. In the case we have for example two different VLANs and also different subnet. In this case, we have a new thing called the L3VNI. So when we have different enter VLAN and or different subnet, so in this case, what we need L3VNI, which is for the routing. Okay. So this is our objective to configure this server in the VLAN 10. With IP 192.168.52, and we have here VLAN 20 in 192.168.62, and also we have another VLAN 10 also 192.168.53. As you can see here, we have steps. So first step, we need to enable the features like OSPF, VN segment, NV overlay, BGP and EVPN. Second step, we need to configure internal routing plus the BGP connectivity, and also we need to configure VLANs, okay, and map it to layer 2, okay, layer 2 VNI, and we have also layer 3 VNI. For the fourth step, we need to create a VRF for a tenant. Let's suppose I have a customer called ABC, okay, because this example we're gonna do like we are in the same tenant, okay. Let's suppose we are a customer called ABC. This ABC has 3 servers in different subnet and different VLANs, okay. And also we need to advertise all layer 2 EVPN under BGP, okay. And we need here to specify what the VRF. This is very important. We're gonna discussed in the lab, okay. Also we need to create a VTAP which is the NV interface in the Nexus, and also define layer 2 or L2VNI and layer 3 VNI. Also we need to enable the BGP for control plane, and also we need to configure BGP for bump traffic, and you can also use the multicast. And also we need to configure Express ARP, okay. And we have step number 7 to configure what? Enable EVPN L2, okay. So now let's move to switches. In the switches, the only thing I do, just I configure the IP addresses. So if you check show IP interface brave, you will see loopback interface 11, okay, /32, and I have Ethernet 11 10.0.0.1 /30, okay. And also if we checking here show IP interface brave, I have here 222 and 10.0.2. So first of all, what we're gonna do, we need to enable the feature. First feature is OSPF, second one BGP, then the feature for VN or VN segments, and the future also we need to configure it NV overlay, and also future enter VLAN, and the last one VN or NV, sorry, overlay EVPN. This is for EVPN, okay. And the same in the Nexus 2, future BGP, sorry, future OSPF, and the future NFV overlay, future VN segment, future enter VLAN, and future or not future NV overlay EVPN. Okay, good. Now let's move to second step to configure internal routing. I'm gonna choose the OSPF plus BGP, okay. First of all, I need to create router OSPF1 with the router ID 111. Okay, good. Then access to the interface Ethernet 1, IP router IP router OSPF 1 area 0, and also for loopback 0 IP router OSPF 1 area 0. Good. And let's move now to second one, router OSPF 1. Okay, router ID 222 and interface Ethernet 11 IP router OSPF 1 area 0, and also for interface loopback 0 IP router OSPF 1 area 0. Let's check now. Show IP OSPF neighbor. Okay, it's full now. If we check in routing table, we have here 222, or we are in the 2. Okay, so 11 via what? Via OSPF 1, and here also 222. I can see it. Okay, if we try ping now, ping 222. Okay, yeah, the ping is success. Now we need to move to configure the BGP router. Router BGP 100. I gonna choose the autonomous system number 100. Then router ID 111. Then address family IPv4 unicast. Then need to mention my neighbor is 222. Then remote autonomous system 100 and update source loopback 0. Then address family layer 2, sorry, L2VPN EVPN. Okay, I need to send community. This is send community extended. Also send extended. It means for example more future, like what, like EVPN routes and so on. Okay. Let's move to second as well. We need router BGP 100. Router ID here is 222, and address family IPv4 unicast. Our neighbor is 111. Remote autonomous system 100 and update source from loopback 0. And also we need to create address family for L2VPN EVPN and send community as well. Send community extended. That's good. If we checking right now, show BGP layer 2 EVPN, layer 2 EVPN summary. Yeah, we can see the BGP up. Okay, that's great. So now step number 1 and step number 2 is done. So what we're gonna do right now, we need to create L3VNI. To create this, we need to create the VLAN, what? VLAN 1020. This is represent what? L3VNI. Let's give a name, L3VNI. And this one is in the VN segment, what? 5000. So here I will map what? Map this VLAN 1020 to what? To 5000. Okay, that's good. After we configure that, we need to create, also we can create the VLAN 10. For example, this is VN segment is 110, sorry, 110. Here we don't have VLAN 20 because this is exist only here, but let's do it. Why? For the future. Okay, let's suppose in the future I want to add here VLAN 20. Okay, exit VLAN 20, sorry, VLAN 20 VN segment 120. Okay, good. Let's do the same in the Nexus VLAN number 1020. This is name as L3VNI. Okay, VN segment is 5000. Okay, all the same because we are in the same tenant and also we are in the same VRF. Okay. Then VLAN 10, okay, VN segment 110 and also we have a VLAN, VLAN 20, VN segment, 120. If you do show VXLAN, okay, we can see this is VXLAN L2VNI. We can see it 10 and 20, and also we can see L3VNI, which is here 1020 VLAN mapped to what? To 5000. Okay, that's good. And also we need to do that here just to double confirm to avoid any issue. Okay. Okay, good. So here all are the same. Okay, great. After we do that, we need now to move what? To create the VRF. The VRF is very important. So now we already done from step number 3. We need to go to the step number 4 to create the VRF. So now let's move to create VRF. Our VRF called ABC, okay? So to create VRF, we need to write VRF context, ABC, okay? And also we need to mention the route distinguisher, okay? We need to do the route distinguisher. Route distinguisher helps us to what? To, for example, if you have a different customer, you're gonna use the same IP address, okay? For example, you have ABC and you have another customer called, I don't know, D, okay? So you can use, for example, the IP 111, okay? And also you're gonna use 111 for ABC as well, okay? This is for route distinguisher. I will write it as auto, okay? So Nexus will generate an RD for me, okay? After that, we need to what? To assign what? The VN or L3VNI. VNI here we have 5000, okay? Because this is for layer 3. When I said VRF, so it means this is a virtual router, okay? So the VNI is represent what? L3VNI, okay? I will not use the L2VNI, okay? This is, I hope this is clear. Then we need to do address family, IPv4, okay, unicast. We need to send what? The route targets to import and export the route from other Nexus, okay, from the other Nexus. So I can do import and export. If you want to use the import and export, so you can use the both. Both, it means export and import, okay? Import the routes and export the routes, okay? Good. Auto, okay, I will do it as auto, and also route target both auto for what? For EVPN, okay, for EVPN. Okay, good. And also let's do the same thing there. VRF context, sorry, ABC, route distinguisher auto, and address family IPv4 unicast, route targets auto or both auto, and sorry, what's going on here? Route target both. Can you get virtual ID? No, it is could not generate RT automatically. What's going on here? I think everything is okay. Let's go to the auto for EVPN. Okay, is the same error, cannot get virtual. Let's see what is the error here. Show run. Okay, we have VNI 3V ABC. Yeah, it's accepted, is good. VLAN 20, okay, 100. Okay, here is good, and here is good, and ABC, roto targets, EVPN, auto EVPN. Okay, good. So now let's, after we do that, we need to go to the BGP, okay, to the BGP to advertise all L2VPN, okay, under what? Under BGP, because we already said what? Route target both, okay, export and import, but imported on which protocol? under what? Under the BGP. Okay, so this is, I need to mention that. So I need to go to the BGP router BGP 100. I will say for the VRF ABC, okay, for ABC, please advertise L2 what? Sorry. Sorry. Here VRF I need to access first in address family unicast or IPv4 unicast. Then I said advertise L2 VPN EVPN. Okay, so when I said VRF, okay, ABC, it means this have a specific routing table or dedicated routing table, not related about the main routing table. Okay, this is separated from the main routing table. Okay, I advertise it. Okay, good. And also I need to go here, router BGP 100 VRF ABC, and please access to address family IPv4 unicast, and advertise L2 EVPN or L2VPN EVPN. Sorry. Okay, great. So now we already configure the fourth step. And right now we need to go to fifth one to create the interfaces, VLANs, and and assign the IP addresses for these interfaces. First interface, we have a VLAN interface, VLAN 120, yes, 120, no shutdown. And here I will say this interface is for or part or member from the VRF ABC. Okay, that's good. And also I need to configure it as L3 to forward IP or L3 traffic, okay, or L3 info. Okay, that's good. And now I need to go to the interface VLAN 10, and I gonna give the IP address. Before I gonna give an IP address, I need also to assign it to the same tenant, to same VRF, because our VRF or our customer called ABC. I need to link this interface to VRF called ABC. Okay, but before do that, we need to explain one thing. Okay, as we know, interface VLAN here we have here in the Nexus, because we have VLAN 10 and we have also VLAN 10 here, right? So here, if we gonna make the routes or make the enter VLANs between 20 and 10, we need what? We need two things. We need the gateway, okay, for these IPs, gateway, and we need what? The MAC address, okay? So what we gonna do? So the only thing, when you have two VLANs or more in different location, so we're gonna use the unicast, okay, one to the nearest. Why? To reduce what? To reduce the broadcast. Let's give you an example. For example, if I put only here, okay, the interface VLAN 10 or the gateway, I put it only here. So right now, if this server wants to reach this server, okay, we'll go to the gateway, okay, then the gateway will say, okay, I will go here, then back, okay, that's this is normal. Okay, let's imagine this server wants to reach what? To reach this server. So now we need to go what? To the gateway. So if we want to go to the gateway, I need to go here, okay, to this server, then go back just to communicate. Okay, so every traffic will be goes like this. Okay, so here what I gonna do? I need to configure IP address and virtual MAC, okay, virtual MAC here, and also I need to what? To configure an IP and virtual MAC, all the same. Okay, And for the virtual MAC, it doesn't matter. You can use it for VLAN 2 and VLAN 10 or any VLANs, okay? But for the IP is mandatory to use different IP if you have different VLAN, okay? So let's do it. So first of all, we need to configure to configure the fabric forwarding. This is fabric forwarding to what? To create the anycast MAC or the virtual MAC. So first of all, I would say fabric forwarding anycast. So here you can give any MAC address. So I need to, for example, I will choose 00 001 1234. Okay, good. And also here conft fabric forwarding anycast 000. Make sure the MAC address same, okay? 001 and 1234. Okay, same. That's the same. So now it's easy to create the interface VLAN. So interface VLAN 20. First of all, I will say now shut down and say this VRF is member from what? From ABC. Okay. After that, I give an IP address. Okay, 192.168.10.1/24. Okay, good. And also I need to say here fabric forwarding mode mode anycast gateway. Okay, to take this this interface is assigned as a MAC address as this anycast gateway MAC address 00.001 1234. Okay, good. And let's move also to the interface VLAN 20. We don't have VLAN 20 here, but as I told you, in the future maybe you need to configure that. Okay, no problem. No shutdown. Okay, VRF member ABC. Good. And IP address 192.168.21/24. And VRF or before VRF already we did. Okay, IP address, then fabric forwarding mode anycast gateway. Okay, good. Okay, let's move to other one. Interface VLAN 10. Now shut down this VRF member from ABC. Okay, and IP address is 192.168.10.1/24 and fabric forwarding mode anycast gateway. Okay, let's move to interface VLAN 20. Now shut down VRF member ABC and IP address 192.168.21/24 and fabric forwarding mode anycast. After we configure those interfaces, so now what we gonna do? We need to create VTAPs. Okay, so we already complete with the 5th step. We need to go to 6th step. Okay, so great. Now let's move to Nexus 1 to create the interface NV1. This is for VTAP. First of all, I will say no shutdown. Okay, and I will say this source interface loopback is 0 for NV1. And also I need to enable to enable the control plane, which is to make sure this is used control plane, not data plane, by using the command host reachability protocol BGP. After we do that, we need to configure the member. The first member we have 110, okay, or VNI, member VNI, sorry, 110. This is for VLAN 10, okay. I will say for any BAM traffic for VLAN 10, unknown traffic or multicast traffic or broadcast traffic, please use the protocol BGP. So how can I say this one? I said ingress replication protocol BGP. This is for BUM traffic. And we have to do one thing called the ARP suppression. Okay, I need to enable something or suppress ARP. So this is suppress ARP. How this is can help? Okay, this suppress ARP. So suppress ARP, for example, I have a server here, okay, and this server wants to what? To reach this server. So first of all, when the packet is going to the nexus, okay, or before go to the nexus, the packet ask for the ARP or asking for the MAC, who is 192.168.62. So before or in the data plane, so how it goes? So it will be goes like this, okay, send the ARP as a broadcast, then going back like this, then give it to VLAN, then this server can reach this server in the VLAN 20. But in this in the sparse ARP, in the sparse ARP here, in the BGP control plane already knows, okay, all the servers here, because this nexus will send all the info layer 3 and layer 2 to what? To the nexus 1, okay? And also nexus 1 knows all info about these servers here and send it to what? To nexus number 2. So if someone, for example, in this case, server asks who is 92.168.62 as or requesting for the MAC address, so this nexus 1 so will be act as an agent or act as a proxy, okay, proxy for what? For this server. So already knows about the info about this server MAC address, directly here will be reply. So this is to reduce what? To reduce the broadcast also. This is the suppress ARP, okay? I hope this is clear, okay? So suppress ARP, so here we have an error. The error, please configure TCAM region for ingress ARP, ether access list, okay, before, okay. So here this is the error, okay, this is a famous error. Here we need to slice the ARP ether access list. What you gonna do if you face this issue? Just you need to go, let's see, show hardware, not show hardware, okay, show access list hardware or hardware access list region or access list TCAM region. Okay, so yeah. So if we try to hardware access list or access list, hardware access list, TCAM, okay, region, which service, the error, ARP ether, okay, region ARP ether 256, okay, let's see, double wide, okay, still the same error, the aggregatism TCAM region configuration exceed the validation increase. Yeah, this is because the resources is not available. So what we're gonna do, we need to decrease the number or decrease one service. Let's see the biggest one, this one. Let's do hardware access list, okay, TCAM region, okay, and I will choose this one, RACL, okay. Instead 1536, I will choose, for example, 128, okay, 128. Error. Let's do it to 56, for example. This is multiple of 256. Okay, good. And let's do the same ARP ether double wide. Okay, now it should be work. if we going to interface MV1 member VNI 110, okay, and sparse RP. Yeah, now it's working. That's good. Okay, sparse ARP is working right now. That's good. And let's go to the second member VNI 120, and also for the BAM traffic use the protocol BGP and also sparse ARP. Okay, so we have two members. If we do show run NVE or interface NV1, so here we have no shutdown, blah blah blah. Okay, member VNI, this is for L2VNI for VLAN 10, and this is for VNI 120 for VLAN 20, and we have the last one for the L3VNI. So for the L3VNI, we said in the interface NV1, I will say member, which member? VNI 5000. Okay, this is VRF associated or associated VRF. Okay, great. So this is about what? The first one. Before we going to the Nexus to directly to NV interface, we need to do the same for the hardware. We need to do hardware access list TCAM region, which one RACL 256. Okay, good. And also hardware access list TCAM region for ARP Ether 256 double wide. Okay, that's good. So now I need to create interface MV1. Now shut down. Source loopback interface is loopback 0. Okay, and please switch to control plane protocol BGP. And member VNI, here we have 110. Okay, then for BAM traffic use protocol BGP and sparse ARP, and also for member VNI 120 use ingress replication for BAM traffic and sparse ARP use it also for VLAN 20, and we have last one for L3VNI member VNI 5000. Okay, this is associate VRF. Okay, good. If we checking right now, show NVE peer detail, I can't receive anything. And also show BGP all, we can't see anything. Why? Because we need to enable EVPN layer 2 VNI. Okay, to do that we need to go to conft, okay, then going to EVPN and do VNI. We have the first VNI is 110 L2 for layer 2. Okay, then we have a route distinguisher auto and route target. Okay, both or route targets both auto. Okay, that's good. And also we have the second one, VNI, which VNI, sorry, VNI 120 layer 2. Okay, RD auto and route targets both auto. Okay, good. And do the same there. Conft EVPN. First VNI is 110 layer 2 and route distinguisher auto, route targets both auto. Okay, and VNI 120 L2 RD is auto and route target both out. Good. Let's now checking if the MVE is up or not. Show MVE peer. Yes, that's great. MVE1 is up now. The peer is 222. Status is up. And now we are using the control plane because we are using the EVPN. Okay, the uptime is 18 seconds. Okay, good. If we checking show BGP all, we can see some routes, okay, or some info about what? About L2VNI and L3VNI. So we can't see any MAC address because we didn't generate a traffic here. So we're gonna do it right now. Let's now try to ping from these VLANs to this different VLAN. Before we do that, we need to assign. Oh, we forget something. 1 minute. We didn't configure the VLAN for this interface and also for this interface and this interface. So let's do it first to try the ping VLAN. Sorry, in the interface Ethernet 1, 2, switch port mode access, switch port access VLAN 10. Okay, now shut down. And also here we have what? We have conft interface E1/2 switch port mode access VLAN 10. And also for interface Ethernet 1.3 switch port mode access VLAN 20. Okay, good. After we complete this, we need to configure this VPC's IP address. Let's I'm not sure about this. This one show there is no IP address. Okay, 192.168.52 and the gate or before gateway 255.50, then the gateway 51. Okay, and let's move to second one. Here IP address 192.168.53 255.255.255.0 and the gateway, sorry, 51. And the last one, I have an IP 192.168.62 255.255.255.0 192.168.61. Okay, nice. And now let's try to ping. First of all, I will ping to what? To my or the server in the same VLAN and the same what? The same network. Ping to 192.168.53. So the ping is successful. Okay. And the ARP, if we're checking the ARP right now, I can see the ARP 6841. Now, if we're going to the same table, we can see in the table BGP table can read what? The MAC address. Okay, the MAC address. As you can see here, this is 6441. Okay, I can see it right now. And this MAC address 683D for this server. Okay, that's great. So now if we try to ping to 62, this is in different what? In different subnet and different VLAN. Okay, 2. Okay, the ping, as you can see, the ping is not success. Why? It should be work. Okay, because let's see, let's troubleshoot. Show NVE peer. The peer is up, and let's see here. Show. Yes, 62. Let's try to ping 192.168.51. Let's see is reach the gateway or not. Okay, very strange. Let's check this interface in the VLAN number 20 or not. Show interface brave. Okay, 13 is in VLAN 20. Let's checking show interface brief. Okay, VLAN 10, okay, 20. Show interface brief. Show IP interface brief. Okay, show run or show run interface VLAN 20. Yes, in the ABC 20. Oh, this is the issue. Look, here we do 21. 21. Okay, yeah. 21. No, not 21. It should be here 60. Let me check 1 minute. Show run for interface VLAN 10. As you can see here, we have 92.168.10.1. No. Here it should be 50, guys. Or we can do one thing. We can do here 10 to avoid any issue. Let's do like that. Or let's keep it 50. Let's keep it 50 and troubleshoot, because this is abnormal. The ping is success because this we don't need the gateway. Okay, we don't need this interface VLAN because they are in the same VLAN. That's why. So what we gonna do, we're gonna configure interface VLAN 10. Now IP address, and I will do IP address 192.168.51/24. Now is true. If we checking again, show run interface VLAN, okay, good. And also for interface VLAN 20, now IP address, and IP address is 192.168.60.61/24. Sorry for mistake, but it's good for troubleshooting. And also show run interface VLAN, I think the same, same issue. Interface VLAN 10, now IP address 192.168.51/24. Okay, and for interface VLAN 20, now IP address, okay, IP address 192.168.61/24. Okay, good. Right now, if we try to ping to first to my gateway, okay, the gateway is working, nice. Let's ping to other gateway, which is 61. Yes, ping is success. Let's now to ping to from this server to this server. This is our objective. Okay, 62. Okay, the ping 62 still not working. Why? Let's try to ping from what? From this server, okay. Or let's see here, show. This is this server, okay. 53. Let's ping to 192.168.10. Oh, sorry, not 10. 50 or 61. The ping is successful. If we go in 62, the ping is successful. So from this server to this server is pingable. So I can ping. There is no issue. So the issue right now between these two servers. So it means there is an issue in this Nexus or this Nexus, or Nexus switch, number 1 or number 2. Before do that, let's generate another another ping to make sure 52 is not pingable. There is request timeout. Something is missed. Let's see it. After troubleshooting, we found one missed config. So if we go in here, show run, okay. So here in the VLAN number 120, which is represent L3VNI, sorry. So as you can see here already, we configured. If we go into Nexus 2 show run, or let's type directly show run interface VLAN 120, so there is not exist. So we need to configure that, okay. I mean the interface VLAN, okay, not the VLAN, because if we're doing show VXLAN or show VLAN, okay, 1020 is exist here. However, the interface VLAN is not, okay. So interface VLAN 120, now shut down, and assign it to VRF member ABC and IP forward. Okay, I think this is the issue. So now we are in this this server. If you make show 192.168.52, if we try to ping to 62 right now, let's see if ping successful. Not yet. Okay, let's ping again. Okay, we are here in the 60, 53, here is 62, ping to 192.168.52. Still we have the issue. So show run, let's check again. On VLAN 1020 VRF, okay, IP forward ABC. Let's check it again here as well. Okay, VLAN, okay, 1020 already defined it, okay, and here we have 120, okay, good. And what about here? Is 5000, okay, good. ABC IP forward done, okay. VRF ABC IP forward, okay, everything is good right now here. If we checking show peer or NFV peers detail, as you can see here, the learn it's only 110. I cannot learn what 120. Okay, very strange. Peer is up, okay, and show NFV peer here detail. I can also only know about what, about 110. Okay, so show run, let's check again. The fabric same MAC, okay, show run, fabric is the same, 1 2 3 4, okay, VLAN 1020 and 1020, okay, 110 and 120, okay, it's good. 5000 already we define router ID and the EVPN BRF, okay, it's good. Oh look, in the VRF ABC we didn't configure what? The route target. Very strange. Context ABC. Okay. Here we need to define VNI is VNI 5000. Show, run again. Okay, now it's good. We forget some config, we missed some config. If we do right now show NFV peer detail, as you can see here, now I learned from control plane 5000, 10, 110 and the 110 and 120, and on that side also show NFV peer detail. I can receive right now what 5000 and 110 because I am in the Nexus 1 and we don't have here 120. So now let's try again to ping to 62 from this server. Okay, so now the ping is successful. Okay, so we discover two missed configuration. The first one, we didn't define the interface VLAN 1020, and also we forget to type VNI under what? Under their VRF context ABC, this one. Okay, I hope so. This is clear. Okay, I see the video is too long, but it's good for learn and also good for troubleshooting. Thank you so much for your watching and consideration. See you in the next video.